Recording or
yep, just turn it on.
All right, cool. All right, welcome everybody. Thanks for joining our Power BI user group. Let me get my screen going. All right. All right, welcome everybody to our Nashville Modern Excel Power BI user group meeting. Today's agenda is to go over announcements, talk about what's new, and then we have Beyond Power BI, Time Intelligence Beyond the Basics from Bill Anton. I'll do an introduction when we get to that section. So quick announcements. Upcoming meetings on March 11th, we have Matthew Roche building a data culture with Power BI. Another announcement is we have a new logo. So we have a new Power BI user group logo, plan to, kind of flood like the different programs and different social media sites and everything that we're using with this logo. So this was inspired by the DC user group logo. So in the background there's the Capitol building. So decided to take our Batman building and put that behind it. And I'm going to try and use that and market that and put it everywhere. So have a brand new logo. So be on the lookout for that as we start to push that out. Also, we have a YouTube channel, so subscribe to our channel. Right now, we have 18 subscribers. Right now, we have 53 people right now in attendance. So if I know how to do math, that should be 71 by the time this is over. New subscribers to our channel. So go to Nashville Power BI user group and subscribe to our channel. We're posting our monthly meetings on there as well, and potentially have plans to, grow this thing out and add some additional content on there. But all our content and stuff is there, and we're just trying to, get more broader as we're in an online world. So subscribe to our channel. All right, job opportunities. So we don't have a recruiter for this particular month's meeting, but I still want to leave a section out there for anybody who has any opportunities, anything that has any, internships, whether data analyst roles, whatever the case may be at your company. So this is a time interactive piece. If you have any opportunities to announce them.
Hey, I've got a quick one.
Yep.
Sorry, I've got dual stuff going on. I actually pulled up the YouTube channel. I hear Will talking in my background. So sorry, y'all. We actually have an opening on our team. It's not for analytics, though. So I just know good people, know other good people. We're looking for a help desk, more tier 2, some system admin type stuff. So if you know anybody in the market, Hunt Brothers Pizza, it's posted on Indeed. So thanks.
Thanks. All right. Anybody else? All right, so then if that's the case, I will mark it for where I'm at. I work for Ryder right now. So we currently have a whole bunch of data analysts and data engineer roles. We are a Power BI shop, so we're looking from levels 1 to 3 for the data analyst role. Similar concept for data engineers. The data engineers will be responsible for creating, any type of engineering, ADF packets, the ETL and all that stuff, and similar concept as well. Data engineer 1 all the way up to level 3. So we have a lot of opportunities at Ryder. They're investing in our analytics. So, if there's something you're looking for, reach out to me and, see what we can make happen. All right, so go into what's new. So Power BI Desktop hasn't had an update since our last meeting. So this is still the same slide from last month, where we have direct query, small multiples, data protection, some changes in data preparation, some new ways of connecting to different data sources, and then you have a service capability. One thing I'm gonna do a quick demo on is small multiples. I find this pretty useful if you have the right use case for it. So particular use case that I've come up with, for those who don't know, small multiples in essence is you're allowed to plot multiple dimensions, categories, however you categorize it, onto the same graph. So the use case came up where I am looking at, say, a product, and I also want to see the subcategory information as well. And then maybe I want to see what that information looks like over time and do some type of trending type of analysis or what have you. So one way to answer this, could be doing a simple table with drill down functionality. So you have your product category as the top hierarchy. You click on the plus mark, and then you have your subcategories and you see the sales information within there. And then you click on it again and you can see what the sales information is what's inside it for each particular day. So it answers that question, but it's not necessarily visually static. It makes your end user kind of have to do a lot of clicks to get that information, not really clear line of sight into the particular answer that you're looking for. So with small multiples, what you potentially do is you kind of visualize some of that same information. So let's say I have the same sales by product category, where I have my technology, furniture, office supplies, and I can see this information. And then to the right, you have your small multiples. So what's being plotted here are all the subcategories. So with that same scenario is I can see what my subcategories information is doing over time. So for example, let's say I selected technology. And so within technology, I see that I have $1 million worth of sales, but I want to know what makes up that sales. With the small categories type, with small multiples type of graph, now you have the ability to put that subcategory into a graph, and you can see that information trending over time. So you can quickly, your end user can quickly see that, hey, the bulk of my sales came in at office machines. And the least amount of my sales came in my telephones and communications. So it's a pretty good way to get quick answers pretty fast, if depending on the use case that you have. So one way to kind of take this a step further is you can do some type of formatting with some DAX. So this is just a really simple solution that I kind of came up with. Exact same scenario, but now I really want to know what my min and max is for each particular category. So if I have exact same scenario, I have technology selected. Now within here, we have our $1 million, but now I can see within each category where my max value is for each subcategory or a small multiple. So it kind of gives some more information to that story you're trying to tell. You could flip it if you want to do the max value, just depending on what you want to do, but it allows you to do some type of formatting as well to quickly call out those insights depending on the story that you're trying to tell. So just a quick example that I came up with, but I think small multiples can be powerful if you use it the right way. And then just to show you, anybody who cares about the DAX behind it, just a simple, well, I won't say simple, just a statement where I'm looking at just the max order sales, and then I'm just doing an if statement where the max equals the max values per subcategory. And to show you what it looks like in the table structure, basically we see our subcategory, our order date, and our sales. What I'm basically flagging is the max value for that subcategory. So we see the one, we see that 13,000. So what's being plotted in the small multiples is all this information, but we're highlighting this max value. And then we see that repeats for our other subcategory. So binders and binder accessories, this is max value for that. We're plotting that, and that's what we're calling out. So that is a quick demo on that. I think it has a lot of room for growth. I think there's some strong possibilities out there if you use it right, but that is one of the new features that I enjoy that I'm trying to use a little bit more. All right, so some of the updates, Power BI page and edit reports. I'm not sure if this audience is using it. I'm not using it as much, but it could be some people that are using it. I think it's starting to grow as well, people using page and edit reports, but the latest update, Power BI report builder published to Power BI service. This now looks and feels similar to Power BI. So as you have that button to publish up to your service, page and edit reports now looks and feels like that. And then if you are trying to use page and edit reports, they built out additional sample reports that are available now. And then there's now a Microsoft Dataverse connectivity portion out there for you as well. Updates for Power Apps, source code files for Canvas apps. There is more GitHub support. There's now intelligence and relevant search. So there's enhanced spelling check-in. There's enhanced recognizing common abbreviations. There's just a whole much more intelligence that they rolled out within Power Apps. Now there's also model-driven app push notifications. So now Power Automate can be leveraged to send you notifications depending on the rules and stuff that you set up. And then there's GitHub connector features for Power Platform. New GitHub connector makes it possible to build self-service apps using Power Apps and Power Automate. If you go out to the Power Apps section, they actually created a demo app for you to leverage and use using the GitHub connector. So if you're using GitHub for your stuff and using Power Apps, a lot of good stuff that came out in this last update for GitHub. And then Power Automate. So people that are using Power Automate, there is a run from here is available in a flow designer. So as one piece, I think this was a request for people that are using Power Automate. So this has been updated. So now you can actually click the run from here in your flow designer, which could help, improve QA or development or what have you. So it's a pretty good feature. Existing variables can now be selected and used as produced variables. And then various actions have been improved to be configured more intuitively. The send keys action now includes a list of predetermined special keys. And then there's a whole bunch of various things out there for actions. Didn't want to just bog down the slide with a lot of text, but a lot of actions have been improved. A lot of good things that are going on out there. And then Power Platform Bootcamp. So Will, I will leave this one for you.
Yep, let me share my screen. Thanks, Sekou.
Yep.
So let me first tell you about the Power Platform Bootcamp. So this is a feature of our user group. We have a lot of people who come to our group who want to learn about these new tools. And so we had an idea, why don't we kind of put together some curated self-directed trainings. There's so many good trainings out there that you could do at your own pace. We'll kind of curate a list and we'll award badges for completion of those trainings. Just kind of add a social component to the learning we're doing together in our user group. So if you want to be a part, this is kind of an opt-in. If you want to be a part of the boot camp, just chat me your email address or message me on Meetup if you want to be a part of it. But basically, you do trainings and get badges, and then we'll award them during our meetups. You can get badges for attending 6 user group meetings or being a speaker at our user group. And you can also get badges for completing projects as well. So if you're interested, send me your email. I can send you this PDF and you can be a part of the bootcamp. Today, I'm going to award some badges. So Scott Fields, I think you may have joined recently, but you have been to 6 user group meetings. I think you've actually been to over 10. So we're retroactively awarding you for your participation. So thank you, Scott. And then Tom Seitz, you have been to more than 15, and we're retroactively awarding you as well the 6 user group meeting badge. And then Carlos Rodriguez, he already completed a Power BI beginner project and had it reviewed by one of our Power Platform or bootcamp reviewers. But he also has come to 6 meetings and gets the 6 user group meeting badge. And then Dawn Kilpatrick, she's got her 3rd badge. So she had a project reviewed by Michael Hewitt this past month, and she's been awarded the intermediate. So we have a certain little rubric that the reviewer uses, and so you could get an award from beginner to intermediate to advanced for the level of your project. So she was awarded an intermediate badge for her project. And then Michael was the reviewer. He gets the bootcamp reviewer, project reviewer badge for doing that review of Don's project. And that is all I got, Sekou, so I'll turn it back over to you.
Awesome,
and
thanks.
Yeah, I was gonna say again, if you want to be a part of it, just message me your email and I'll send you that PDF.
Thanks. Congrats to everybody. Keep chugging away at these badges. It's great stuff. It definitely makes you better by doing these different things and completing all these different things that we have out there. So thanks, Will, for that. All right, so with the next one, we will be introducing Bill Anton. He's doing a Power BI Time Intelligence Beyond the Basics. Just a little intro on him. Bill Anton is an expert in analysis services and experienced data warehouse practitioner. In 2013, he founded OptiFlex Solutions, a consulting firm with deep experience in enterprise scale architecture, design, and performance optimization of analytics services and Power BI solutions. He loves eating and spends most of his free time convincing his beloved wife to adopt more golden retrievers. Bill's great. Consider him a friend of mine. Bought me and my wife a baby registry gift. So it's really awesome. Good guy. Met him in New Orleans last year. And just, yeah, I speak really highly of him. So I'm really excited about this presentation. So the floor is yours, Bill.
Hey, appreciate the warm welcome. All right, let me see if I can share my screen here. Yep, there's the button. All right. Everybody see the screen? The title slide?
Yep.
Okay, good. Just have to check. All right, so welcome to Power BI Time Intelligence. So this is Beyond the Basics. Here's my contact information and the resources. So some of the Power BI files, scripts, and presentation slides are available on GitHub under that link. So if you have any questions afterwards, feel free to reach out. Okay, there we go. Just a little more about me. Here are all the golden retrievers. And that's what I used to look like before COVID. And then here's OpFX Solutions. Heard all about it. If you have any issues, need some help, feel free to reach out. Okay, so on to the meat and potatoes. So what is time intelligence? So really, this is just referring to measurements and analysis of various metrics over time. It's probably the most common form of analysis in general business intelligence. So if that's not enough of a reason, I'd also argue that time intelligence, writing these sorts of calculations, is perhaps the best way to start wrapping your head around two very important concepts with the DAX language, and those are evaluation context and filter propagation. So here's the agenda of our presentation, and we're going to start with date tables. These are key for writing time intelligence calculations. Power BI has some, or DAX, I should say, has some built-in time intelligence functions. So we'll look at those and kind of dissect and see how they work and ultimately decide whether or not they're going to suit our needs or if we need to enhance them, which is going to lead us into a conversation on evaluation context. And this is a really key concept for writing DAX. So I think this is a good introduction to it. It's a very deep topic, so there's plenty more to self-study afterwards. And then we're going to move on to some harder stuff. So not necessarily hard, it's just different. It's some common scenarios that come up when writing time intelligence logic that may not necessarily work with the out-of-the-box DAX functions for time intelligence. So we'll look at some of those. All right, but first, date tables. So first thing is we need a date table in our model, period, full stop. So a date table could be created a number of ways. We could create one in DAX. Right there in the Power BI file, there's a couple functions to help us get started. Calendar, we just provide a start and end date, and it returns a table with a single column of dates between the two date ranges. And then from there, we can continue to write more DAX to add additional columns, such as like a month and a year. But this is probably not a good way to go. Ultimately, we would probably want to build our date table closer to the source data so that it can be used more pervasively across various solutions. Calendar auto, this is also an interesting one that a lot of folks immediately gravitate towards. You don't have to provide any start and end date. It will look at all the data type columns in your model and then create that single column table of dates that range from the first date it finds to the newest date it finds. And this can backfire, as you might imagine. A lot of folks use special date values to represent certain things in data warehousing and BI. So for example, there might be a date value of January 1st, 1900 to represent an unknown date. And there might be a date value of December 31st, 2999 to represent some unknown date that we just know it's in the future. And these can end up bloating your model. So I'll show you a quick example of that. Another place to create your date table, though, if you don't want to do it in DAX, is you can create it in Power Query. Here's just a quick example. This is very similar to kind of the calendar function where we're essentially in that first line there. We're specifying just a start and an end and then a number of days. And then we build off additional columns from there. So again, It's an option. I don't love it. I would prefer it to be in the source, but you don't always actually have access to make changes in the source. So if you're somehow working on some data source where you don't have the ability to create a date table and it doesn't already have one, well, you're stuck, and maybe Power Query is a good place to do that, or even a data flow, depending on how you're laying out your Power BI environment. But ultimately, if your tables or if your data source is a SQL Server, as many folks here probably do have, then you can also just create one in SQL. And here's just a random one that's generated out of thin air. And you can also create one with magic. And by that, I simply mean Power BI has realized, at least the group responsible for feature delivery, they realized that date tables are so important. And in fact, instead of coaching people to create date tables, they just went ahead and built in the option to automatically create one. And there's two places over here in the global area. You can check this box and have auto date time. And what this does is it creates an additional date table for each date column in your model. So while this will help you in the short term, at an enterprise level, this is a bad design pattern. So we typically disable these and we create our own date table and bring that into the model. So don't do that. There's a lot of drawbacks, like you can't create additional columns, you can't rename columns, just don't do it. Okay, so let's jump into a quick demo here. This one will be quick because I want to get into the other stuff. So pretty much all the demos we see here are based on a data model that looks like this. We have a fact table, and then we have a dimension for customers and product and eventually date. But in this case, we have our auto date time enabled, right? So that's over here in the options section. I was thinking about it. There we go. All right. So let's check off here. I have it checked in here. And because I have this turned on, we can see over here, the due date, order date, and ship date are all date columns in my fact table. So there's a date data type. And what it does is you can see that it has this little calendar icon next to it. And that means that there is an auto date time table that's created underneath the covers. So if I cancel this, it basically allows me to create, hierarchical structures like this. So I can create a matrix and I can drill in from the year to the quarter to the month without even having year, quarter, and month in my model, right? So this part right here, this date hierarchy, and then these year, quarter, month, day columns are just created for me. But I don't want to do that, right? So I want to use my own date table. And we can switch over here and we'll go to the all tables model. And here I've got a date table and I'm going to unhide this. And I'm also going to go ahead and turn off the auto date time. And he's thinking really hard about what menu. Let's pull up. There we go. So I'm going to uncheck that. And when I hit OK, it'll get rid of all those date tables for me. And this is a bit of an inconvenience at first, right? Because I lose my hierarchy. So now I just have this date column, right? But I can recreate this. I can just use columns from my date table instead. And here we see that we have quite a bit more columns in our date table than they give us out of the box. And I didn't really do a good job of cleaning this one up. But really, when you see a date table, you'll see that there's a ton of columns here, and the majority of them aren't intended to be used by your report designer. Most of them will be used by person writing DAX calculations. They're what I call them is helper columns. And we'll see a lot more of that in some of the other demos. But we can create interesting helper columns and achieve certain effects with them. So for example, this is just a plot of sales amount over time, okay? And let's say that I wanted to have this on a report or a dashboard that always shows the current year to date. Right, so I can create an additional column, a helper column, in my date table. So current year to date, for example. I'm going to put a filter there on this, and I'm going to switch it to 1. Okay. And so right now it thinks that today is, looks like September 10th, 2013. That's just the data set I'm working with. But really this flag right here, right, is a 1 or a 0, and it's calculated based off of like the get date function, for example. So every time the data is refreshed, this changes, and there's a 1 for every date in my date table that is in the current year-to-date range. So if I refresh this, and I can do that with just this date table. If I refresh this, then the current year-to-date is actually going to progress to 2014. So it should be February 16th, 2014. And so our chart will change. Okay. It looks like I have some a problem with my date boundary. The fact table doesn't go past the 26th of 2014 or the 28th of 2014. Nevertheless, the example is basically having this here and setting this to 1, and then publishing this to the Power BI service and setting a scheduled refresh for each night. Every time the data set refreshes, it advances the current year-to-date flag. And so every time a user comes and pulls up that dashboard tile or report, it's always reflecting the current year-to-date. So this is a nice, easy way to produce some sort of reporting asset that is always showing, some sort of current filter. And you can use it not just for current year-to-date, but for more complicated comparisons, like current year-to-date versus prior year-to-date, all sorts of that, whatever's requested, right? Okay, let's switch back. Oh, one other thing about the auto date time, right? So here's an example, and we've got one table in here with 4 columns, and there's only 2 rows of data in here, right? But we just have January 1st, 1900 to December 31st, 9999. I think these are just special dates. And if we look at this, and everybody's familiar with DAX Studio, hopefully. If you're not, this is a great tool. And one of the use cases, besides writing DAX calculations, is our ability to see how our model, the cardinality of the various columns in our model. So here is the main table, and we see that we've got 4 columns, and we have auto date time enabled. So we've got these tables created for us. Now, if we come over here and look at the metrics, this will load metrics, basically details about our data model over here. So in memory, let's just look at the summary. In memory, this Power BI file is almost a gig, right? And it's 4 columns, 2 rows, right? It's just showing that this is a beast of a date table, right? 3 million unique values. It's taking a lot of space. Okay, so this is just it's an extreme example, but it shows you can get a lot of bloat and for very limited functionality that you get out of that. Okay, let's switch back to our slides. Okay, helper columns, right? And this is just an example. You'll probably have a lot more, but you can have all sorts of things, like whether or not the date was a work day. So holidays, weekends, just depending on what industry you're in. Sequences, right? So from the beginning of time, right? So not just what month of the year is it, what month of all the months in the date table is it? And this will allow you to do things like rolling period calculations that jump calendar boundaries. So if you need to do a rolling, 16 or 18 months calculation, you don't have to worry about handling the fact that, you're doing some data arithmetic and you And you start at June, the 6th month, and okay, got to go all the way back, 18 months. What is that? Really, you can just subtract 18 from the current month sequence. Relative period flags, we looked at a quick example of that. It's good for creating filters, but these can also be applied within a DAX calculation, and we'll see some of that, certainly. And then relative period indexes, so counting forwards or backwards from the current period. So the current period, whether that's a month, a quarter, semester, a year, right? Positive numbers indicate future, and then negative indicates past periods. And so again, this is all just scratching the surface, and you will add a bunch of these depending on what sort of calculations you're trying to create. One quick note, there is relative date slicers. So if you use date column in a slicer, you have the ability to format that as a relative date slicer, and that gives you the ability to do certain things. There are some drawbacks here, right? Because first of all, your functionality is limited, and also this is relative based on the current date UTC, which not always lines up with how data is loaded into your source. For a lot of data warehouses, current date actually represents yesterday's data because that's the data we've processed into the solution. Okay, a couple of key takeaways. I'll let you kind of read through this. And if you have any questions, feel free to unmute and ask. Probably the biggest key here, aside from having your own custom date table, is to standardize and centralize that date table across as many solutions as you can. Your users will come to appreciate that standardization, and so are the broader population of report developers. Okay, so
hey, Bill, there's one question in the chat.
Oh, yeah, let me switch over there real quick. Okay, there we go. Okay, when creating a date table and you have fiscal years ending other than 12/31, that's a great question, right? I always create my date tables with the first and last date in the table lining up with calendars. And the reason is because I will not use, and we're about to talk about this a little bit, but some of the time intelligence functions, the built-in DAX functions, they have an additional parameter where you can specify, well, when does your fiscal period end or something like that. And that comes with some limitations. So what I typically tell folks is to include your own fiscal calendar within the existing date table. And so your date table will always start on January 1st and end December 31st, right? Because it lines up with calendars. And then you'll have fiscal columns, so fiscal day of year, fiscal month, however your fiscal calendar works. That will be managed inside, but you'll use custom calculations to handle fiscal, perspectives. Right. So this will make a little more sense once we get into some of these calculations. And if it's not clear, please ping me again. We can kind of dive deeper into that. Okay. Lots of time intelligence functions right out of the box. My favorite place, if I need to go figure out, well, what is this doing? How does it work? Is dax.guide. I've found this for most cases, this is one-for-one, which you get with the Microsoft documentation. What I like about this is, it's gotten, there's been a couple instances where it's had additional detail, like on specific use cases and examples that helped explain, what's the difference between this function and another function, or this, or why shouldn't I use this, that sort of stuff. And it links a lot to the SQL BI articles on DAX. And so these two guys, Marco and Alberto, they're just, they're the best when it comes to DAX, and they put out the best material. And so having that just a click away from when you're already looking at reference material is super helpful. So, and there's a whole section on time intelligence. Okay, like I said, lots of functions. A couple of key points here. They don't work with actual time, so they should be called date intelligence functions. They also don't support things like weeks or semesters or any sort of non-standard period or grouping of dates, right? There's limited support here for fiscal calendars, right? So there's like quite a few limitations there. Like the first day of the fiscal year must always be the same day for every year, which you would think is pretty, common, but it's not necessarily. Some fiscal calendars start on different days of the year. And then, it can't be the 1st of March, which is some weird historical bug. The quarters always start on the 1st of January, April, July, and October. This is a little weird. So things to be aware of. Okay, the biggest one, though, is that they require customization in many common real-world scenarios. Probably the biggest one would be boundary detection, and then any sort of attempts to compare periods of different sizes. So if you're comparing month over month, well, some months have more days than other months. So is that a good comparison? Right? That's just an example. Okay, so let's dive into some of these, and we're going to write a bit of DAX here. Okay, let's close this out. Oh, and here's just an example of a date table in SQL. So it's a basic date table, and then it's just enhanced with a bunch of SQL inside of a view. All right. Let's start here. All right. Give me a minute. Here we go. Okay, so we're going to start and we're going to write some of these calculations. And this is going to kind of be our first foray into some of these time intelligence functions. Let me make a little more space over here. Man, it's really thinking hard. Okay, so we've got sales amounts, and let's write a year-to-date calculation. Right. So we'll write the sales amount. Let me make this a little bigger. Okay, so we've got a couple ways to do this. So I could write total year to date. And I want to calculate my sales amount. And then I just specify the date column of my date table. And I glossed over this, but when you have your own date table, you sometimes need to mark that table as the date table. And all that really says is it signals to the Power BI that, hey, this is my date table. And part of setting it as the date table or marking it as the date table, you're specifying also a column in that table that contains dates. Right? And there's special properties that this column needs to abide by. For example, it has to have sequential dates with no gaps, right? And non-repeating. And so anyway, this is obviously set as my date table. And by having that marked as a date table, it unlocks special functionality here. So sometimes if you use these calculations, these DAX functions, and you're not getting the expected results, you might have forgotten to set your date table. So let's go ahead and just hit enter there. And then we'll drop this out onto the matrix. All right, so at the year level, right, it's the same as year to date. So when we really test this, we'll just dive into a month level. And we see that, okay, so this is the first month, second month, and then we basically just have a running total that resets at the end of the year. So yeah, this is in fact the correct year-to-date logic. And we also have another way to write this though. So for example, I can item D2 of this. And this one makes use of the calculate function. So in this case, I'm saying I want to calculate the sales amount, but I want to change the context first. Don't worry, we'll get to that. Dates year to date. And so here I'm specifying my date column again. So one way to kind of classify a DAX function, is it time intelligence or not, is whether or not you have to specify your date column, right? And so here I'm just saying calculate the sales amount, but first change the context for dates year to date. And we're just going to gloss over this for now because we'll get into it quite a bit more detail later on. But the main point is that there are a couple different ways to write the same logic in DAX. And we'll see even more ways, right, when we get to some of the later sections. But again, these values match, right? So it looks good. Okay. So now let's move on and let's do a prior year calculation. All right, so in this case, I've got another time intelligence function I can use. And I can use this kind of general approach to it. So I want to say, calculate the sales amount, but do it for the previous year. Okay. And let's dump this one out into our matrix. Okay, and so we can see that at 2011, our prior calculation is showing for 2010. So that's looking good. All right, so what happens at the month level? We got a bit of an issue, okay? So previous year only works at the year level. Well, we've got another function we can use for the month level. And let's just go ahead and write one for the previous month. And I'm not going to do formatting here, but we've got previous month function. And this one will work at the month level for us. Oops. But it will not work at the year level. It works at that year level because there's only 1 month in the previous year. But if we dive down here, that's not right. But it's correct at the month level. Okay, and so at some point we have to say, well, how do we make these into a single measure? And I want a single measure that works at any level of my, date hierarchy, right? And so we'll come back to that. But what a lot of folks end up moving to is the same period last year calculation, which is great because there's a function, and we'll see that. And it just works right out of the box. You don't have to write the function. You don't have to add any more complexity. We'll just go ahead and write that real quick. The drawback, though, is that it's not the equivalent logic. So sales amount, same period last year. All right, so we'll throw this one out there. And let me move some of these up. So everything's blank at 2010 because we don't have any 2009 data. At the year, this is working. This is what we expect. At the month, it looks like it's working, and it is based on what we're actually doing here. But as you can see, this is matching this, right? And that's because it's January of the previous year. Right, so this is better depending on what our requirement is, but this is certainly easier than what we'd have to do to actually get a true previous period. So we're going to circle back around to that. But to really kind of understand what's happening here, we've got a neat little trick we can use to debug some of these functions. So let's switch over here. And let's, kind of figure out, well, what's actually happening when I use previous year or previous month or same period last year. And the answer is that it just has to do a lot with context. And I'm going to copy a function over here just to save some time. And I can come into my date table, and it doesn't matter where you write these measures. I'm just a little OCD. So if this is debugging date stuff, then I'll put it in my date table. So we'll call this date debug. And let's just talk about what's happening here. So I am essentially just outputting a string. This is a measure that outputs a string. And the way it works is it provides a date range from the min date in the current context, and then it writes the word to, and then the max date in the current context. Okay, so we'll just put this in here and then we'll drop it into our visual. There we are. Okay. So we can see here on this line of 2011, it's January 1st, 2011 to December 31st, 2011. And when we go down to the month level, right, we see this is January 1st to January 31st, February 1st, February 28th, right? So that's as we expect. These are the dates that are in range in this row, okay? And so now how do we take this and figure out, well, what's the previous year doing? Well, we can just build on top of that date debug function. So we can write one that's date debug y. And we can do it the same way that we actually wrote the previous year functions, but instead of sales amount, I'll just calculate my date debug and use the time intelligence function that I'm curious about. Okay. All right. So if we look here at 2011, here's the current context. It's January 1st to December 31st, 2011. And here we see that the prior year is doing December 31st to January 1st, right? But we're also doing that at the month level and at the date level. So this tells you where that number's coming from, although it's a little more obvious when we're going from a prior year calculation down into a month level than say when we're doing a prior month calculation, but we're at a higher level. Okay, so this date debug approach can be really helpful in figuring out where you are in the current context and what you need to do to get to the desired context. All right, so before we go too far with that, let's dive back to our slides. And so we saw some total year-to-date versus the calculate plus dates year-to-date, and this is just two different ways. We have the same thing with month-to-date. Problem with month-to-date, though, is that sometimes if we get it to the year level, it doesn't really make sense, right? So this actually is, so this is month to date at the year level, but this represents December of 2011. So that's not super obvious, right? We could use our date debug function with something like the dates month to date calculation to figure out, well, what are the dates this is calculating for? We've got previous year issues, right? So if we go to the month level, we have repeating values. And then previous month, but again, we have problems at the different levels of our hierarchy. And then we look at the date debugging approach. And this is, again, super helpful because all we have to do is swap in our time intelligence function, and it gives us a date range of dates that are in context. Right? And then we saw the same period last year. This is a super common one to go to because it just works at all levels, right? But the problem is it's not exactly the same logic as prior period. And so here on the right, we have prior period, where at the year, we want to see the previous year. The quarter, though, we want to see the previous quarter, not the same quarter in the previous year. Right? And so to tackle that, it's a little bit different. So let's dive back into our calculations. I'm going to switch to another file. Any more questions while we wait for this file to load? Seems like it wouldn't take that long. It's only about a meg. Okay.
Power BI seems to take longer and longer to load these days.
It sure does. I remember back in the day when it used to be like a 70 meg download.
That's right. It's
now it's ballooned up.
Triple that size. No, I was going to say the debug is a great tip. I'm going to start using that. Thank you.
Yeah. Yeah, and you can certainly use it. You don't have to write your own metric. I find myself just popping that into some more complex metrics and spitting that out in the return just to see, well, where am I right now? I thought I was here, but this is telling me that I'm not.
That's super helpful.
Yeah, good. Okay, so here we're talking about how do we actually get to that single metric where we show prior period? Because that leads to year over year and percent growth, and we can write it in a way where we can do it in a single calculation, then that simplifies our model for our report users. So they don't have to sit there and be like, oh, well, I'm setting this up so that, it's calculating at the year level. So anyway, it's a good thing to do. And we'll just flip through here real quick. And this is just showing the year level. Wow, this is brutal. Okay, there we go. So we can write prior year. It works at the year level. And we can write, prior quarter. Same thing with months. They work at those individual levels, but now we need to do it against a hierarchy. And so how do we do that? And the answer is we're going to use some extra functions. So I'll call this one sales amount prior period. It's bigger here. And actually, I'm just going to copy and paste this. So you have to watch me do this. Okay. So let's talk about what's happening here. First, we've just got a switch statement with a always true. And then we do checks. And this is a sequential checking kind of pattern. So while we don't actually test anything, we always go into our branches. We stop, and these branches are ordered intentionally from the most granular to the least granular, right? So we say, is month in scope? If so, do our month calculation. If quarter's in scope, do our quarter calculation. Else, if year's in scope, do our prior year calculation. Or if we're at the all level, nothing's in scope, then just display blank. And you could fill this in with some other logic if you intended that to calculate differently, like maybe the last year. I don't know. It just depends. So anyway, pop that in, and then we'll dump this into our matrix. Okay, so here we have our sales amount, prior period, and at the year level, it seems to be doing what we expect. And at the quarter level, it also seems to be doing what we expect. So this matches this, and that matches that. Okay, and we can see at the month level, it's also working. Just some formatting differences here. But nevertheless, this is working. And we also have another way to write this. So instead of using is in scope, we could write it with the old school way of doing it. And that would be the if has one value. So and I'm also going to copy and paste this because I don't want to type it. so this works very similarly. And so we go into our switch with force true, and we check, do we have one value on month, right? Because if we're here at the month level, then we only have one value. But if we're at the quarter level, then it's likely that we have three values, right? And so this would be false. And we go to the quarter level and do quarter, or the year level and do year. There is a difference between these two, and it's very subtle. And in fact, I'm going to gloss over it because it takes a bit of time to explain, and I'll just point you to a slide for the sake of getting to more demos, right? And here's a quick show of the kind of example. So in this calculation, we're using the ISINSCOPE, and in this calculation, we're using the HASONEVALUE approach. And at the lowest level, at the month level, it's showing the same value, and that's okay. That's what we would expect. The trick here, though, is that we've got a slicer over here. And so we're actually filtering for July 2012. So the ISINSCOPE, this is the total amount for quarter 3 in 2012. And this is the total amount for the year in 2012. But here we just see this is the current filter, and it's showing July of 2012 for all of these. And so which one's correct? And the answer is it depends on what you're trying to do and what the requirement is. And so here's a link from the SQL BI guys where they go in and talk about the actual differences here. The Cliff Notes is that the ISINSCOPE checks to see, is the column that's the argument for ISINSCOPE, is that used in the grouping criteria? So if you think of a matrix, you know, the month is used in the grouping level, right? And here, it's not used in the grouping, right? So at the quarter level, and that's why we get this calculation. The HASONEVALUE simply just checks for the number of values that are in context. So at all three of these levels, actually all four at the all level, the month still only has one value because we're filtering it over here. So it's a very nuanced difference. So if you get into a bind here, this is the link for you. Okay, evaluation context. This is the part I kind of want to just get to because this is the meat and potatoes. And evaluation context is really just the context in which a DAX measure is evaluated, which is not helpful. So let's look at an example. So each one of these cells right here, this first one, this first one here and down here, each one of these is the same measure, sales amount, but there's a different context in which the sales amount measure is evaluated. So this line is being evaluated in the context of 2010. And right here, it's in the context of 2011 and 2012. And this is actually January of 2012. Okay, so we define a context and then we evaluate the expression within that context. And this plays a role. Your data model is a big one, and this is filter propagation. Right? So if we are trying to calculate the sales amount for January 2012, well, what's happening here is by evaluating in this cell right here, we have a filter on January 2012, which is a column from our date table. So we filter on these rows, and that filter propagates down to the sales table. So we end up with a sales table that's filtered for only the rows with an order date in January 2012. And then we sum up those values. Okay? And that's filter propagation. So it's evaluation context and then filter propagation. The cool thing about it is it works with multiple tables. So you don't just have to force it down one, but you can do more complicated stuff. So if we need to see our sales and our inventory for January 1st, 2012, we can just filter the date table for January 1st, 2012, and that filter propagates to all the related tables. Anywhere with this little arrow that's pointing towards the other tables, that's the way the filter propagates. Right? So how does this apply to time intelligence? Right. Well, because what we're doing with time intelligence is we are detecting the current context. Do we have some column like years, months, or days on our rows? And when I say rows, it's easy to think of things in terms of a matrix when you're calculating, but it could just as well be the x-axis of a line chart, right? So what is on your grouping, your axis, your grouping axis, or the rows of your matrix, right? Detect that current context, and then from there, figure out, well, what are you actually trying to do? You create a new context. So if I'm, on this year and I need to go back a year because this is a previous year calculation, well, I need to create a new context for the dates that fall in the previous year. And it's all relative based on what's the current year and the current context. So once I create that new context, then I just calculate whatever the metric is within that new context. And that typically falls into the realm of using the calculate function. So, detecting current context. There's a lot of places where current context can appear. So we can have filters on the filters pane of our Power BI report. And this will create a context in which all the calculations are evaluated within. We can have slicers out on our report. We can have cross filtering, which creates context or impacts context. And then in visuals too. So like this column right here has a context of 2011. Okay, so it comes from a number of places, but the good news is it's pretty easy to detect our current context. We've got a couple of functions here like min and max, selected value. These all help us detect our current context. And in fact, that's exactly what we're doing in this date range debug function. We're detecting the current context of our min and max date, and we're just creating a fancy little label to help us see what that range is so we can return a single value. So let's do some context work. And I should have kicked this off before leaving the VM. Okie dokie.
Bill, do you use any of the built-in time intelligence functions, or do you mainly write them yourself with your calendar table columns?
So if I'm trying to move quickly, I will often just use the DAX time intelligence functions. But if it's something that's less proof of concept, more going to be productionalized, I will typically write my own. And I may use some of the DAX time intelligence functions.
Yep.
In there, but I'll just enhance them with some like boundary protection and stuff like that. And we'll see some of that. And there are certain scenarios where you have to write your own. And we'll certainly get to that right here. So here we're going to revisit some of these. And in this one, I've got a prior year calculation. I believe it's already written. And it's already out there, okay. And this is just, let's look at that. So this is just using the previous year function. But I might write this a different way. I might use more of a generic pattern. So sales amount, if you want to be 2, okay. And the first thing I'm going to do is, for a prior year, I need to determine, well, what's the current year? Okay, so current context here, and I can say selected value. I could say, what is the max? There's a whole bunch of options here. I'll just use selected value. All right, so this tells me, well, what year is it? And then I will create a new context. So current context, prior year. And here's the first bit of trickery. And this is very generic, but let's talk about what's happening. Let's get it written. Okay. So first off, variables are a super welcome enhancement to DAX. It allows you to really break out your logic into steps, whereas before we had to write it in just like a really long, hard to kind of really wrap your head around single statement, which was really nasty. But here we're stepping through this and we say, let me create a variable and capture the current year. So if you envision being in the matrix and on your rows, you have 2010, well, you're going to store 2010 in this variable, right? And if you're on the row of 2011, you're going to store 2011 there. So then we come down to here, and this is one of the cool things about variables is we can store a static value, or we can also store a context. And so in this one, I'm actually going to store a context. And so the context I'm storing here is I've got the all date. So remove any filter that's on the date table. Okay, so again, if I'm on the row for 2011, I am looking at the date table with a filter on year equals 2011. So I'm saying remove that filter. Right, so this gives me everything in the date table. And then I want to apply a filter, in this case to year, and I'm just using some simple arithmetic. So take the current year and subtract 1, and then apply that filter to the date table and stick that in a variable. Okay, so now I can have my result. Oops. If I can spell here, there we go. Where I'm going to calculate my sum metric, in this case sales amount, but I'm going to do it in the new context we just created. All right, so here, in this case, we're storing a static value, but here we're saying calculate sales amount, but first apply this context, and it's this context. So basically put me in the prior year and then calculate sales amount, and then return that value. Okay, and this will return the same value as our original calculation. Okay, so that looks good. And we can do the same thing here with a year-to-date calculation. And so here we've got a year-to-date, and we're using the dates year-to-date approach. Okay, and I can write a new measure here. And in this case, I am going to capture some more info, current context. In this case, I need to know what is the max date. And here I can say, well, let's get the max date. Okay, and another helpful variable is current year. And I can just say, give me the year of this. And this is just to help me write the calculation where I'm creating a new context. But here I'm storing, I'm capturing, detecting my current context. And now I'll create a new one. And I'll say dates year to date. Oops. And we will do a filter. And I'm going to remove the filter on my date table. And then I'm going to reapply it. So in this case, I want the year to stay the same. But I want the date to be less than or equal to the max date. All right. So if we're looking at, let's just say this row, 2013 of November, right? The max date on this row is going to be November 30th, 2013. Okay. And then from that date value, I can just grab the year. But here I'm removing all that filter and then I'm reapplying it. So I still want it to check the range for being in 2013. But now I want to include all dates from January 1st up until November 30th, 2013. Right? And then the rest is just the same. We'll calculate some measure in our new context, and we'll return that. Okay. So that seems like a bit of a chore to do all that just to get the same calculation. It's a lot more typing. Why didn't we just use the function? Okay, and that's going to take us to our next slide. All right, so we looked at this, and this is very simple. Ultimate time intelligence pattern. Current context, create your new context. Your new context in time intelligence is almost always based off your current context, maybe 99% of the time. So you need to know that current context, right? And then calculate is just your Swiss Army knife function, allows you to calculate a measure within some context. And in this case, we store the context in a variable. Pretty good stuff. All right, so why did we actually go through the hassle of writing it out in those 3 steps like that when we could have just used the built-in time intelligence functions? Okay. Well, there's a couple of reasons. So unsupported time periods, weeks, semesters, right? So there's no prior week. There's no, same week last year kind of thing. Same with semesters, and same, especially if you get into the scenario of fiscal calendars that don't fit in to the restrictions of using the DAX, the Microsoft fiscal calendars. Calendars can be really weird, especially if you use some of those other standards like 445s, that sort of stuff, especially, in college. I found education to be a very tricky one, especially when they have not just, a regular calendar, fiscal calendar. They've got a recruiting calendar. They've got calendars where, certain periods are very different in size. Start dates are not always on the same day each year. So it's really interesting. But nevertheless, we run into a lot of these scenarios in the real world. Incomplete periods is also a common one. So I call this simply like boundary detection. So for example, are you comparing a complete period, the current period, against, a complete period in the past? So if we're comparing the month to date for this month, well, we're only halfway through the month of February. Yeah, so we can't really compare that to the full February of last year or to a full January. It just doesn't make sense. It's not fair, right? So how do we account for that? And the way we account for that is by wrapping our calculations in, some boundary detection type of scenarios. So let's dive into this. I don't know if we'll get through all of these, but I'm not going to write them all out. We'll just kind of dissect some examples. We'll just look at the end ones. Okay, and we've got a quick question here in the chat. I missed it. But the question is basically, how much do you want to clean up your data before exporting to Power BI and applying DAX functions? The answer is almost always. And how much do you want to clean it up really depends on how dirty the data is or incomplete. But and I might be a little old school in this kind of opinion, but I do not like doing any sort of data cleanup or transformation logic in Power Query unless I have to. So I prefer all sorts of data modeling and transformations to happen in the source system before it even comes into Power BI. And I totally acknowledge that that's not always possible. A lot of times you have to build on top of some data sources that you don't have control over, and so you have no choice. But really, you want to do as much as possible before you get it loaded into the model at the very least. Okay, so let's look at some of these. The first one is weeks, right? And if we wanted to do things like what are we doing here? Week to date, prior week, oh, prior weeks. Okay, so there's no prior week function or previous week function. And so we can write a calculation like this. So if we're looking at weeks, we've got, you know, our first week, and this is our prior week. And there's only 1 week in 2010, so that's kind of a bad year. Let's fold this out. Okay, there we go. And so that should be the last week of 2011, and then we see here, it's just standard. And so what's happening, right? Because we don't have a previous week, we have to write our own. And this is where we first kind of get a nice little taste of a helper column in our date table, right? So I've got a column called week sequence, and it just manages the, it's a sequential number that increments for every week in my date table. And it increments past or across months, years, and all that, right? So the first week, week sequence 1 is the very first week in my calendar, and then the last week is probably something in the hundreds. But here I can just do simple arithmetic to get, you know, previous week. Previous week is just the current week sequence minus 1. Okay. All right, so let's look at another one of these. We've got a little more here, and I'll throw this one in, and we'll talk about what's happening first. Okay. Okay, so we've got some future weeks in here. All right, so if today is September 21st, 2013, that puts us down here. Okay, yeah, so this is our first one, our first calculation. This is our second version, right? And we stop here. And why is that? And that's likely because this is an incomplete week. So if we look at this calculation, we just have some boundary protection. Everything about this is essentially the same. Right? We're calculating our week sequence. We're calculating some additional information here too. So what is the minimum date in the current context? Right, so that just says for week 39 of 2013, what's the very first date of that week? Okay, and then we say, what's today? And this is not today as in actual non-deterministic today. This is what is today according to my calendar or my date table. And so this is where it just has a 1, it just has a repeating value of what it thinks the current day is. And this would be something that'd be populated by your ETL. So what was the last day that was processed? That's today, right? And so we do everything else the same, right? We create our new context, and then we calculate our return value, but we only return the value if today is greater than the min date, right? So this is just boundary protection so that we don't display something here. And then from this, we can get into like rolling averages. So if we look at this, we just got a rolling average here. And this is just playing with our dates, with our ability to create new context, right? So we're still just grabbing our week sequence, but now we're creating a new context that is a range of week sequences. Right, and then we average that, we divide because we know there's going to be 4 periods in a week. But even this has problems because at the beginning of time in our data model, there may not be data for all 4 of these weeks. So in the first week in our data model, this will be computed just based off of the 1 week time. And so we need to do more protection there. So we'll write this another way. Right, so now we've complicated this even more, and we have a separate measure that represents the first order date in our entire data model. And we use that to create our new context. Right, so not only that, but we also now have a check. Right, so now we're checking to see, all right, well, we're going to calculate this, but then we're going to make sure that we have 4 weeks of data. So this returns true if there are 4 weeks of data in this context. Right, and so all of this is the same, but now we just have additional checks here. So do we have our future boundary protection in? Yeah, and then this is our history boundary detection is in. And as long as both of those are true, we'll return a value. Otherwise, we'll return blank. So this is kind of where rubber meets the road, and why you can't necessarily just depend on the out-of-the-box calculations, right? So this would apply even if you were not doing something like an unsupported time period, such as weeks or semesters. And so even if you're doing months, you would still need to make these checks. Okay. It's kind of a bit. How's everybody feeling? We'll look at some more examples, because it only just gets worse from here.
Bill, I just wanted to comment. We usually end at 1, but since I guess this is another benefit of the virtual meeting is people can go whenever they want. I'm digging what you're showing, and I think you can go a little bit longer, and if people are able to stay, they can stay, and we'll also catch it for the recording that we can post for people who are watching asynchronously.
Okay, yeah.
But yeah, I love what you're showing, and that last example you showed, the way I normally would have done it is if there weren't 4 weeks, I would have counted the weeks and used that as the divisor. But I think I like the way you did it, because the user knows when they're looking at it, it's always a complete period. So I like that boundary protection method.
Well, I mean, you bring up a good point. You could certainly check, right, and change your divisor as well. So that's certainly another way to handle it. It's a great way to handle it.
Yep.
And it really just depends on either what's required, and if the requirements are a little flexible, then you want to make sure that you're communicating that through some sort of documentation. This is how this calculation works.
That's right. That's right.
Yeah, it's often like one of the first things that gets cut from the scope of any project. It's like, right. Okay, we just add these features and it documents itself. And the answer is no, it doesn't. But yeah, so we can go through, let's go through one more. And then I just want to switch back to the slides and throw out a couple of references that I think might be helpful. So here's an example where we're looking at same period last year, and we have a whole bunch of different things, right? And so remember, today is, according to this data model, September 21st, 2013, right? And so we've got, sales amount, right? And then this is just for the current period. And then here's the same period last year. But if we're using same period last year calculation to create some sort of year over year or some sort of growth calculation, then we need this to accurately reflect the current period. So for example, we need to stop future months. And then in fact, this current month, this is September of 2012, but this actually represents the entire month of September 2012. And here we see that we're actually only going, 2/3 of the way through. So we need to get even more fancy, and we have this D3 out here where this is kind of, this is a comparison where it actually only goes up to September 21st of 2012. And so while if we start comparing these things, it looks like we're doing okay, but we're actually doing a lot better than it looks. And so we'll just jump right into this last version. And a lot of this starts to look the same after a while. Okay, so it might look like a lot now, but here we're just getting our current context. And how we grab our current context really depends on what we think we're going to need to do with that current context. Like, are we in the same period last year, you know, and do I need the date granularity, or is it good enough to just know that it's, you know, 2013 and September? Well, in this case, we're getting to the nitty gritty, so we need to get down to the date level. We need to have a very precise range of current context. And then we need today to know what our boundary is for that current period. And then here, I'm just adding a little step in between to set me up for creating my new context, right? So the start date is always going to be the min date, but the end range date depends. So if today is greater than the max date in the current context, then put the max date. Otherwise, use today. Okay, and so then I calculate a valid dates context. So this is the same year, but it's with my new boundaries. And this is just one way to do this. But what I do is I create a filter or an evaluation context stored in this variable. And then I'm using the built-in time intelligence function to calculate the same period in the previous year. Right, so this can work. I can use this time intelligence function to create a new context and store that context variable. So this represents, you know, the period, say, in that current month of, what was it, September 2013, the 1st to the 21st of the current year. And then this represents the 1st to the 21st of the prior year, right, which is what I'm really after. And so then I could just calculate my final amount, and then I do boundary detection and return the value if everything looks good, okay? So this is a lot more involved than just simply using same period last year. I guess is kind of the gist of it. But anyway, this stuff, what you'll see is you'll start to recognize some patterns in here as you write these, and eventually you'll end up with writing this pattern, you know, once, and then you can apply it to all sorts of calculations. So like this would be a good one for same period last year with boundary protection and current period protection. And then you could use something like calculation groups to apply it to a whole bunch of different measures. But that's a bit outside of the scope. So let me switch back to these slides real quick because I want to talk about these additional resources. So we looked at all this stuff here. Okay, so here's my stuff. I'm a book learner. So like I like to go to books when I'm trying to learn something. Some folks do better with like video courses and stuff, and that's great too. But I would recommend these. And so these first two are by Phil DeMark. He's great. I like the way he describes or explains certain concepts. And so, you know, I'd say it like this, you know, if the material in the session felt a bit complex and hard to follow, you might want to start with this first book. If you understood what you saw, but you're not sure you could reproduce it on your own from scratch, then probably start here. And then eventually everybody's going to get to here if you're working with Power BI enough. This will answer all of your questions. You probably have to read it a whole bunch of times. It'll make your head hurt, but it's good stuff. And then here's some other helpful information. Stacks patterns. This is great for figuring out how to set up certain things. They have a time patterns series that walks through a lot of the examples that we saw in some of the demos. But it'll get you thinking along the right terms. How do I set up my data model? How do I approach these sorts of calculations? And then these two are just obviously great. Tabular editor being the biggest one. If you're authoring complex DAX measures like this, it's doing it in Power BI is not a great way to do it. So anyway, that's all I've got. I know it's a lot of material. Here's the link to the Git repo with all the presentation slides, and I think this is being recorded, so you can always come back here. But if you have any questions, feel free to just reach out. Happy to talk shop.
Thank you so much, Bill. This was great. I was reminded of what Rob Colley called the time intelligence function that's similar to this. He called it the greatest formula in the world because it's so useful in every model, wherever you go.
Yeah.
But I feel like you modernized it here with variables and kind of breaking it down into steps. So thank you for this. This was very, very helpful. And I think I saw a lot of good feedback in the chat. So thank you for joining us today.
Yeah, thanks for having me. It's been a real pleasure. And I'm subscribed to the YouTube channel now too, so it should be at least at 20.
Nice. Yeah, I'll check it afterward. Thank you. But yeah, we really appreciate it. And thanks so much.
Cool.
And thanks everybody for joining. Well, we have our next month meetup is posted, so you can RSVP today on meetup.com, and we'll catch you guys next month.
Great. Thanks so much, Will.
Yep. Thanks, Bill. Bye.